In this section, we're going to go over the more traditional style of factoring, which is really reverse foiling. And this is the one where the better you are at foiling, the better you are at these. So, for example, this is when we're for factoring trinomials with an a value of 1. Remember that the a value is the number in front of the x squared. And so the a value being 1 makes it the easiest of the two types. Okay, you're going to have when a is 1 and when a is not 1. And so what we're really trying to do is we're really trying to take this trinomial and turn it into the two binomials that, when foiled, created x squared minus 7x plus 12. And so the strategies that we employ is, obviously we know that the first term times the first term has to equal x squared. And we know that last times last has to equal positive 12. So we think to ourselves, well, what numbers multiply to 12? 3 and 4, negative 3 and negative 4. It might be positive 6 and positive 2, negative 6 and negative 2. And it could be positive 1 and positive 12, or negative 1 and negative 12. These are all factors of 12. However, those factors have to add up to whatever this middle number is. So which one of those factors adds up to negative 7x? It's these. And so we get x minus 3 and x minus 4. And if you FOIL that out, you'll see that you'll get x squared minus 4x minus 3x plus 12. And when I combine those middle terms, notice that I get what I started with. And so factoring a trinomial requires you to kind of think of the factors. And the rule is, just so you can kind of see it in a different way, or one of the strategies that I use is this X method here. And I say, okay, it has to multiply to a product of A and C, and it has to add up to whatever B is. Well, when A happens to be 1, remember that this is A, this is B, and this is C. So we're like, okay, it has to multiply to 12, and it has to add up to negative 7. Well, what factors make that happen? Well, minus 3 and minus 4. And that's how I do it, right? I get x minus 3 and x minus 4. So let's try some. So again, here we look and we're like, we notice all of our a's on this page are equal to 1. So that makes this problem much easier. So I have to think of all the factors that multiply to 6 but add up to 5. And by 6 and 5, I mean positive 6 and positive 5. And so I know that my combination of factors in this case is going to be positive 3 and positive 2. So it's going to be x plus 3 times x plus 2. And you can always FOIL to double check. Okay, now again, I know that negative 3 and negative 2 multiply to 6. However, their sum is negative 5, so it doesn't work. I know that plus 6 and plus 1 also multiply to 6, but their sum is positive 7. I know minus 6 and minus 1 also multiply to 6, but their sum is minus 7. And so the only one that had a product of 6 and a sum of 5 is this one. And so again, the better you get with your foiling, or the better you are with your foiling and combining those middle numbers and stuff like that, the better, more sense this is going to make. So again, with this one, I look and I know that my product has to be negative 6, but my sum has to be negative 1. So again, I start thinking of my factors. Now notice that this is a minus here. When the product is a negative, that means that we have different signs. When the product is positive, they're the same signs, right? So my two factors have to have the opposite signs here to equal a negative 6. One number is going to be bigger than the other. And I know that the negative number is going to be the larger number. Because again, notice that if I have, think about it, let's do negative 3 and positive 2, or positive 2, or negative 2 and positive 3. I also know that this could be negative 6 and positive 1, or it could be negative 1 and positive 6. And when we talk about sums, they all multiply to negative 6, so they all meet this criteria. However, minus 3 and positive 2 is going to equal a minus 1. Minus 2 and positive 3 will equal a plus 1. This will equal a minus 5, and this one will equal a plus 5. And so what you notice is the larger number will be the same sign as the sum, right? When I add those two things together, I'm going to get a negative 1. And the reason my 1 is negative is because the larger number is negative. So if this is negative, my larger number has to be negative. So I know my answer here is going to be negative 3 and positive 2. So x minus 3 and an x plus 2. So again, when I look here, I know they're going to have the same sign. Now you might say, well, which is it going to be? Is it going to be plus plus or minus minus? Well, it's going to be, this is going to be the sign of it. It's going to be minus minus. Okay? And so again, I'm like, okay, well, what numbers multiply to 8 and add up to negative 6? Well, that's minus 4 minus 2. So x minus 4 and x minus 2. And so we just get to more complex, we get to bigger numbers, but again, same concept. I know my product has to be minus 24 and my sum has to be minus 5. So let's think of products, right? I'm going to have, this is going to be different signs, right? And this is going to be the larger of the two, right? The larger one's going to be the negative. Well, I know this is going to involve 8 and 3. And I know it's going to be a minus 8 and a positive 3 because that would give me the product I'm looking for and the sum. So x minus 8 and x plus 3. Now, when I come to this one, I'm like, okay, what numbers multiply to positive 1 and add up to positive 1? And there are none. The only factors of 1 are 1 times 1, and 1 times 1 would equal a sum of 2. So this can't happen. So this is not factorable. When I get to the next one, again, I need a product of negative 18, and I need a sum of negative 3. I know that's going to be minus 6 and plus 3. And again, the better you get with your multiplication facts and stuff like that, this makes this step very easy. X minus 6 and x plus 3. And the last one, my product is 2 and my sum is 3. So it's going to be 2 and 1. So x plus 2 and x plus 1. So now we start to get to the trinomials that have an a value other than 1. Notice in this problem the a value is 2. And this is a little bit different. And again, I like to use, I don't like this option 1, which is basically guess and check or trial and error with the factors of the first and last term. I'm going to show you how to do it. I know that other teachers, I know Miss Ferrier, for example, likes to use guess and check more. So if you see her videos, there'll be a lot more references to trial and error or guess and check. I'm going to show you what the guess and check method is, and then I'm kind of going to skip it, okay? So what we do here is we know, again, we need to have these two binomials, and we know that these two last terms have to multiply to negative 15. We know that the first two terms have to multiply to equal to x squared. And we know that when we do the outer and the inner in FOIL, that they have to somehow end up with a sum of a plus 1x. And so we got to think of, okay, what are our first and last terms going to be, right? So we start out by looking at the 2x, and we're like, okay, well, what are factors that multiply and give us positive 2x squared? Well, that could be 2x times 1x, or it could be 1x times 2x. So I guess that's an option, right? Either one. And then when we get to negative 15, we're like, well, what factors can multiply to negative 15? And we're like, okay, that could be minus 5 and positive 3, or plus 5 and negative 3. It could also be plus 15 and negative 1, or it could be minus 15 and positive 1. And so we have quite a few different things that we're going to check. And so what we may end up doing is we're going to start, let's say we start with the first one, and we do 2x and 1x. We know that 2x and 1x will multiply to 2x squared, which is our first term. So let's try this combination. Let's try it with that. So we'll do minus 5 and a plus 3. And so when we do that, again, we know first and last are going to work out. First is going to be 2x squared. Last times last is going to be minus 15. It's the O and the I in the FOIL that is going to be tricky. So the outers in this case are going to multiply to 6x, and the inner is going to multiply to minus 5x, and together that equals 1x. Well, guess what? I got lucky that the one I chose is the correct one. If you get lucky that in your guessing and checking you pick the correct one, that's great. But what if I hadn't? What if I hadn't picked this order? I mean, I know this is the answer, but what if I hadn't started with that? What if I had started with, let's say, this one? I would have a plus 5 and a minus 3, and my outer and my inner would end up being minus 6x and a positive 5x, and my sum would be negative 1x, and it wouldn't work. Or what if I had done the numbers in a different order? Because I could have also done 3 and negative 5 instead of negative 5 and 3. And that wouldn't have worked either, because I would have come over to here and I would have done minus 3 and 1x, or rather plus 3 and minus 5. And if I had done it in that order, I would have done my outers and I would have gotten minus 10x, and my inners would have been plus 3x, and I would have gotten minus 7x. So even though I was using the correct factors, if I put them in the wrong expression, matched up with the wrong first term, it wouldn't work either. And so guessing and checking is great when you do it the first time and it works. But when you don't put the right order, you could be here for a very long time guessing and checking. And so it really isn't my favorite method. My favorite method is option 2. And so I'm going to kind of focus on that. So I take that same problem from the last one, and remember that I do this little x, right? And remember that in my x, I know that my product has to be a times c, and my sum has to be b. And so remember that in the first ones where a was 1, we didn't really do 1 times c. We just took the last number because anything times 1 is itself. But now that the first number is a 2, we do have to do a times c. And so what we end up getting here, when I do a times c, I know that my product is negative 30. And I know that my sum has to add up to the middle term, the b value, which is plus 1. And so I have to start thinking of factors that multiply to negative 30 and add up to positive 1. And I know that that's going to be positive 6 and minus 5, because plus 6 and minus 5 will add up to 1 and give me a product of negative 30. So what I'm going to do is I'm going to rewrite this trinomial, but instead of using the combined middle term, notice that, this is f, this is the o and the I combined, and this is the last term. I'm going to make the middle term, I'm going to expand it out to include the outer and the inner. In other words, I'm going to take these factors and I'm going to do plus 6x minus 5x and then minus 15. So again, first term stays the same, last term is the same, but the middle term, I'm going to break it down into the two factors that created it, or the two terms that created it. And by expanding it out and turning it in from a trinomial to a 4-term polynomial, now you remember that in one of our last videos, you learned how to solve 4-term polynomials by grouping. So you're going to group the first two and pull out the GCF, and that's going to leave you with an x plus 3. You're going to go to the next two, you're going to pull out the GCF, and that's going to leave you with an x plus 3. And then you're going to take out the x plus 3 as your GCF, and that's going to leave you with 2x minus 5. And so here are your factors. Same factors we got on the other slide, guessing and checking, however, or your binomials. However, this is the way that I do it, and I'll do a lot of practice on it, and hopefully it'll help you. So again, we come here, we see a trinomial, we see that the a value is other than 1. It's not equal to 1. So you know you're going to multiply your a and your c, and you know that your middle term is your b value. So you ask yourself, what numbers multiply to positive 6 but add up to negative 5? And so that's going to be a minus 2 and a minus 3. And so you come back to your problem and you keep the first term the same. You keep the last term the same. And this middle term is going to be expanded to minus 2x and minus 3x. And so all you're doing is turning a trinomial into a 4-term polynomial. Now you can factor by factoring out the GCF. I'm going to pull out a 2x, and that's going to give me an x minus 1. I'm going to pull out a minus 3 here, and that's going to give me an x minus 1. And now that I have that parentheses, that x minus 1, which matches, I'm going to pull it out as the GCF of that expression, and I'm going to be left with 2x minus 3. And this is my factored form of that problem. Again, keep going. I'm going to go here. I see that my a value is 2, so I have to multiply. 2 times negative 27 is minus 54, and my sum is minus 3. And again, what factors multiply to negative 54 and add up to a negative 3? Well, that's negative 9 and positive 6. So my first term is going to stay 2x squared. My last term is going to stay minus 27. And my middle term is going to expand to 2 terms. It's going to be minus 9x plus 6x. And by doing that, I'm now able to factor by grouping. And so I start out wanting to factor using, for example, the GCF. Same thing we've been doing. And the only GCF between 2 and negative 9x, 2x squared and negative 9x, is x. So I get 2x minus 9. When I come over to here, I'm going to factor out my GCF of this, and it's going to be a 3. And I'm going to get 2x minus 9 as well. So I know the 2x minus 9 will be my GCF, and my x plus 3 will be my numbers. Now, somebody asked me, well, what happens if you don't write it in that order? Like, for example, let's say I have the same factors, but instead of 2x squared minus 9x plus 6, you do plus 6x minus 9x minus 27. Okay, in other words, these middle terms, you swapped up the order. Well, let's see what happens if I do that. I'm going to take the first two, and I'm going to factor out the GCF of the first two, which is going to give me that. I'll take the second two, I'll take out the GCF of those. Again, my parentheses match here, so I know that x plus 3 is going to be the GCF I pull out, and it's going to leave me with 2x minus 9. And notice that I ended up getting the same exact thing. It's just the order of the binomials was different, but the product and the trinomial in the end will be the same. So even if it doesn't matter the order that you put these two numbers, they will end up working out. So a few more problems. Here we have a challenging one because we have this really large 8. Okay, now in all of these, if you can ever factor out a GCF, absolutely 100% you need to do that. However, none of these had a GCF to factor out. So I would obviously, when I see a big number like that, I would really try to factor out a GCF. Unfortunately, there isn't one here. So you actually do have to figure out what is the product of 8 and 18. And so you get 144. And the sum has to be 51. And so you have to sit here and really figure out what are factors of 36 that add up to factors of 144 that add up to 51. And that could take a little bit of time. I mean, I know it's 1 times 144. It's 2 times 72. It's going to be 3 times 48. And then you notice, oh, it's 3 and 48. So it is going to take a little bit of time. I get that. But again, if you know your multiplication facts, you should be okay. So again, you come here and your first term is the same. Your last term is the same. And your middle term becomes 3x and 48x, sorry. And so that becomes the terms. So you come over to here and you start out by trying to factor out the GCF of the first two terms, which is just x. And I get 8x plus 3. When I come to the next one, I factor out the GCF of the next two, which is 6. And I'm going to get 8x plus 3 again. So 8x plus 3 is my common factor. And then what's left over is the x plus 6. And so those are my factors for this problem. And if in doubt, FOIL it out and check and make sure that you're right. Okay? And then the last one is a little simpler, I think. Again, your product is A times C, which is negative 18. Your sum is positive 17. What numbers multiply to negative 18 and add up to positive 17? Well, that's positive 18 and negative 1. And so again, your first term stays the same, your last term stays the same, and your middle term expands to two terms. So you get plus 18x minus 1x. And so now you're ready to factor by grouping. So you take your first two and you factor out your GCF, which is minus 6x. That's going to leave you with x minus 3. Over here, I'll factor out my GCF, which is minus 1, which leaves me with x minus 3, because I pulled out a negative. And again, these two things match, which is what we want, so that becomes your GCF here. And then you're left with negative 6x minus 1. Now, that is one way to solve this problem. A second thing, if you noticed, is that this problem started out with a negative 1 or negative 6 here. And if this was a multiple choice question, I doubt this answer would be there. Okay, and the reason is because we really don't like the idea of this negative being there in the front. And so one of the things that happens is whenever you see a trinomial and the first term is negative, it's in standard form, but the first term is negative, I would say contemplate factoring out a negative 1. That's going to leave you with 6x squared minus 17x minus 3. Now, you'll still factor the remainder the same way you did before. You're going to do 6 times negative 3. Now you get a minus 18 product. The sum is a minus 17. And now your factors are going to be minus 18 and positive 1. So again, we leave that negative 1 out there. The 6x squared stays the same. We get minus 18x plus 1x. And the last term stays the same. We still factor the GCF out of each term. So the GCF of the first group is going to be 6x, which is going to lead us to have an x minus 3. And the GCF of the second one, since I don't see 1, I'm just going to do 1. And that's going to leave me with x minus 3. And so again, I see I got that same x minus 3, so that's going to be one of my factors, and then my 6x plus 1 is going to be the other. And now I have this answer, which again looks kind of similar. Notice you have the x minus 3, and instead of having minus 6x minus 1, we have this minus 1 out here and 6x plus 1. If I was to multiply and distribute this negative 1 to that factor, I would get minus 6x minus 1. So mathematically they're the same. However, this would be the preferred one, and I would almost guess that if this was a multiple choice question, this would be the answer choice that would be there, as opposed to this one, okay? They're still correct, not a problem, but again, the preferred method. So when you see the first term has a negative in it, factor the negative out prior to doing all your factoring, because that's going to be the preferred method.